الرحيم الحمد لله والصلاة والسلام على رسول الله Muhammad bin Abdullah wa ala alihi wa ashabihi wa mawala wa ba'd. Good evening, my listeners. Once again, good evening, my listeners. On our today class, our SWAP Academy online class, if you are new to this channel, don't forget to like, subscribe, and also share to the needies. It's going to be on measurement and units. And this class basically is for Jamb students, and why students can also practice as well. But basically this class is meant for Jamb, those people preparing for this upcoming Jamb exercise. I wish you best of luck on that. So under this measuring and unit, which is measurement and what? Measurement and unit. Under this measurement and unit, we are going to do some, we have a measuring tools, we have some subtopic under this, but what we are going to actually enter today is going to be on a subtopic under this topic, which is dimension. What do I call it? I call it what? Dimension. Most of these students find this dimension somehow hard, but believe me, if you follow me and you put your listening ear, everything becomes what? More simple. What is even dimension? We have to check in the topic of what is dimension. Before you can start saying apple as an example, you have to know what is even A, what is B, what is C, what is D, before you start spelling dog, word, and so many things. So let's quickly see the definition of what? Dimension. Note that in this class, dimension, generally in physics, it is the art, for those people jotting down, it is the art of using an enclosed bracket. It is the art of using an what? Enclosed what? Enclosed what? Bracket. This is an enclosed bracket. To denote, we have mass, we have length, we have time, we have current, we have temperature, which is temperature, we have luminous intensity, and so many more. We have magnetic flux. Magnetic flux. All these things, the art of using an enclosed bracket to denote them, are all these things that I put in board is what we know as basic or fundamental quantity. All these things, from mass, length, time, current, temperature, luminous intensity, and magnetic flux, all these things are fundamental what? Quantity on the board. And they are also called, another name for fundamental quantity is also the same thing as what? Basic what? Quantity. So we're still coming on that under this subtopic. But today we are mainly focusing on what? Dimension. Now the art of now using enclosed bracket. For what is this? Mass. And we use another enclosed bracket for length, which is capital, it is in the block form, capitalized form. This is also in capitalized form. Then time is also in capitalized form. Current, which you can either use I or you can either use A. I mean the unit, or you use the what? The symbol, anyhow it is. And so temperature, you use K. So the art of using an enclosed bracket, the solving that involve the using of enclosed bracket for this capital M, L, T, and all this being putting on the board is what we know as what? Dimension. So dimension is the art of relating this with one another, solving some question regarding the unit and also regarding the dimensional form. We are going to be seeing some examples on this. That is just the definition of what? Dimension. The art of using an enclosed bracket to denote M, capital L, T, I, A, and K. For those people preparing for Jamb, this is the most standardized form, but if they didn't put bracket like this, they put ML. When you are solving it, it's still the same thing. But you know, we are defining it as a physics what? Student. Let's quickly see some exercise under this dimension. Let's see some exercise, whereas we'll be using this to what? Solve so many questions on that. Let's see that. Now, this is a beautiful question being asked by Jamb. In what year? Year 2016. Question number 20 what? Number 23. The dimension of a work and energy are what? The dimension of a work and energy are what? Firstly, know that work and energy are the same thing. Work and what? Energy are the what? Are the same thing. So whatever we get for this dimension is still the same thing as what? Has this. Secondly, we have said the definition. We have put in, haven't we put this down? We have said the definition of this dimension. Now we input. First thing I want you to do, for those people watching me, listening to this particular topic, is that go and memorize some formulas regarding this particular topic. Believe me, if you can memorize formulas, because it is formula we are going to be using in solving this particular aspect of what? Measuring and unit. Once you have your formula intact, then you can start subjecting all these things inside it, then you get your answer. Hey, this is the options. These are the options given. The first thing is that you have work. It's still the same thing as work done in physics. It is force times what? Distance. That is the formula. You can see from offhand, right? You have to go and cram it for you to know. The second thing to do is that it is work that you have to break them. Find the dimension for this first, then find the dimension for this, then match them together. How do we do that? Note that force is what? Force is what? Mass times what? Acceleration. Isn't it? The dimension for mass is what? Capital what? And close bracket. Capital what? M. That is the dimension for mass. For the acceleration, we have done with that. For the acceleration is what? Velocity over time. The pick them, you will still break them. Pick V. V is what? V is D over T, which is displacement over time. Hope you are following me. That's why I say cram formulas. It is very simple. You have to just cram. All upon, what are we having here? We are having T. But let's quickly solve this, which is for the velocity, displacement over time, which is a what? Vector what? Quantity. That is direction. Now this, D, displacement is the length. And I told you that based on the definition, anything distance or displacement, they are measured in what dimension? L. And close bracket L. All upon. What of T? T is also measured in and close bracket what? Capital T. Now let's try and figure it out. We have solved that of V. Now this one at the down top is also capital what? Capital T. I've matched everything together. Now all we need to do now is that we have what? We have A to be what now? To be enclosed bracket. You can match this and this together. Enclosed bracket what? Enclosed bracket. Put this T. You put it, law of indices. Put per 1 here. Because this thing is coming up to come and make this. Put per 1 here. By what? Divide by capital what? Capital T. This is their big divide. All we need to do, A will now be now enclosed bracket L per T. Then try and change this to times. How we put under Bodmans? Put 1 here. That means 1 will go up. This will come down. Times 1 over what? Enclosed bracket what? T. I hope you know what I did here. It's just a mathematical expression. All you need to do now, based on law of indices, this is T at all. This is T. Pick 1 T. Then what? Then divide through, because this is all upon 1. Is the divide sign. Change the divide sign to what? Minus. All we need to have here, enclosed bracket L. This is T minus 1. This divide will change to minus. This is having what power? Power 1. Then you put 1 there. Are we together? Hope I'm not rushing. Then all you need to do now is that you have it, solve this. It will now be enclosed bracket what? L, T, minus 1 minus 1. That is, you are owing 1 naira, you are still owing 1 naira. Making what? You are owing 2 naira. This is the dimension for acceleration. Because in this topic, the scope is that when you are solving one, it gives you the clip to another one. So if you are asked in Jamb now to find the dimension of acceleration, this is the answer. But that's not where we are really going. If you are asked in Jamb to find the dimension of velocity, we don't need to still explain that again. That's what we solve here. Are we together? All we need to do, we have do that of A. Then we are still under force. Let's match it up. We have do that of M, that of A. this is A, this is M. Match them together. Therefore, our force now will be what now? M. You can match everything together. A is what? LT per 2. LT per 2. This is dimension for force. Then come down here, put what? M L T per 2 times dimension for D is what? Or you know it's a distance. It is L. Capital L, enclose bracket. All these things to enclose. Then match them together. You have done with your work done. Then you pick your correct answer. What would that be? Law of index said we are having head here, pick one. And then you plus their power based on this what? Multiplication. This will now be what? M L, this is 1, this is also 1. 1 plus 1, T, we have T here, per 2. Or will now be what now? M L, this is 2, then what follow? Per 2. Are we together? Now, our work done now, it will be what now? It will be M L 2 per what? Per 2. You can put an enclosed bracket, but if the options doesn't require putting an enclosed bracket, there is no problem. Now let's check the answers here based on what Jamb asked. Is it this one? Check, correlate it with this. Is it this one? This is wrong. This is not this one. Is it this one? It is not this. What of this one here? It matches it up. You can see. So our answer, right, correct answer here is D. Is C. ML square T per 2. Now that's one question. They can ask you, what is the dimension unit here? Jamb can also ask you. Mass is what? What is the standard SI unit for mass? It is kilogram, not gram. Then what is the standard SI unit for length? It is meter. But you know, yeah, it has a square. What is the standard unit for what time? You know, are you thinking of minutes? No, it is seconds. Then you put S. But it's having -2. You put -2. This is another beautiful question that Jamb can see us. They can ask you find the dimension of work as they require, or find the dimension unit. This will be the dimension unit. Kilogram, meter square, per what? Per second what? Per second square. That is that under that. So since we have gotten work done, and we are asked to calculate energy, I told you they are the same thing. So they have the dimension for this is also the same thing as this, which is option what? Option C. Now this is another beautiful question from Jamb. It's very simple. All you need to do is just to cram the formula. Once you are good, we are good to go once you have your formula intact, offhand. Now, which of the following is the dimension of Young modulus? This question, firstly, what is even Young modulus? This question is from what? Elasticity. I think you are with me. Under stress, strain, and other kind of thing. Young modulus. Now, these are the options. What to come to your mind? The symbol for Young modulus is done something of this or Y, anyhow you want to. All you need to do, what is the formula for calculating Young modulus? It is what? Stress over what? Over strain. Now, let's break this one. Stress is what? Stress is still the same thing as pressure. For those people that is asking about the name of another word, another name for stress is also the same thing as what? Pressure. That means in my next video, I won't be doing dimension for what? For pressure. Since now I'm doing dimension for stress under Young modulus. I think you have gotten that one. All you need to do, what is the formula for calculating stress? It is force over area. Force over what? Area. Now, already, I don't need to do force again. I think you are following me. First question, we have treated force under work done. So I'll just put in, I'll substitute in my dimension for force that we done in the first video. And area, we haven't talked on that. Then what follows? Force over area. Let's quickly solve that one. Force is what? Force is ML C per 2, isn't it? This is for the force. Now what follows? We have area. Area is also the same thing as length. But you know, area, the SI unit is, if you can note, the SI unit is also, even in math, it is always meter square. So now, this meter square, and anything meter, it is an SI unit using me measuring what? A distance or length. Are we together? So therefore, we have it to be L square for the dimension. And close what? L square. So whenever I'm seeing area now, you know, since it is area is L, length times breadth. So I'll be making use of L times N, which is L square as the dimension. So the dimension for this is L square. Now what follow? Try and match them together. You know, we haven't touched this. We are still under stress. try and match them together and come down here. How to match them based on law of indices under mathematics? This is M, this is L. We pick one L, we have the same base, pick one L. What follow? The power here is 1, the power here is what? 2. Then you said 1, divide we change to what? Minus, under law of indices. What are we having? 2. How together? The T, we are having T here, part 2. All you need to do is that try and compute that. ML, 1 minus 2 will give us what? Will give us what? Minus 1. Then T power what? T power 2. This is the dimension for what? For stress. Or what? Or pressure. Anyhow it is. And now, Jamb can ask you, you know this is where we are going. What will be the dimension unit? Now, what would that? This is mass, which is kilogram. What of L? Meter, but is having per 1. This is what? This is time, which is seconds, per 2. Are we together? Kilogram per meter per second square. That is another question. That is not where we are going. I just chip in that. So, what follow? What followed is that since you have done something on stress, remain what? Strain, for we to get what we are asked to solve, as Jamb requested what question. Now strain is what? Strain is, don't think of anything, strain is extension over length. Extension what? Over length. And know that anything extension, it is length. Or this is also what? Length. The dimension for extension now will be what? Will be L. The dimension for length now will be what? L. Divide will be. Now this, it has no dimension. L cancel L. It is what? Dimensionless. They can ask you in Jamb. That is another question. Strain happens to be dash. Is it dimension or dimensionless? It is dimensionless. That means it has no unit. Meter, meter. They settle one another. And they also have no what? No dimension. That means it's only stress that we are left with here. Are we together? So therefore, what would that be? What would that be? That means Young modulus. Automatically, it has no strain, only stress, according to what I explained just now, which is ml per what? Ml per t per square. Where is that? Let's check the options. Is it this one? No. Check this. Is it this one? No. Is it this one? No. Check this one. It's the same thing. Ml per t. This option D is the what? Correct what? Correct answer. Let's quickly do another one. I'm picking the complex one is that these are all the questions that they do ask. This is also a Jamb question. I didn't put the options because of the time factor. Find the dimension of EMF. What is even EMF? Electromotive force. E stands for electro. This motive, this force. Now, what is the formula? Let that ring in your mind. Please cram the formula. It is W all upon what? Q. Not W. W all upon what? Q. Are we together? Now, what follows is that this is work done, isn't it? And the work done, we have done the dimension of the work done. What is the dimension of the work done? According to what we done, is we said force times distance, if you recall. So I don't need to be doing that again. It will be ml per 2 nam and what? What follows? We have that of L. I'll break that. This is for the force. This is for the what? This is for the distance. Force times distance. But for those people still watching me again, it is very easy. Force times distance. There's no any magic there. This is mass times acceleration times distance we change to dimension is L. This dimension of this is M. Dimension of this is what? It is L per what? You know, it is velocity over what? Time. Distance over time. Are we together? Then all upon time. This will be what? L. We have done that in our video. This will be L per 1. Then this follows. What do we have? That's why we say it is per 2. We have this should be divided by t per 1 divided by t. Let me put. Then let's raise it up. That's what I did. L t. This is what? This is per 1. Then bring that down times what? T. if you raise it up, that's what we get here. LT per 2. That's what make me to put this. There's any miracle here. That's what make us to what? Put what? 2 there. That means A will be what? A will be what now? A will be L this. It will be L per 2. That is for the what? That is for the what? That is for the acceleration. Are we together? That is for the acceleration. Just try and put in that in these parameters. So the reason why I'm not doing this is that I've solved it early in the class. So it will be what? Done now. Since we have solved it, I don't need to still do that. I quickly recap it in that something. I hope you have got that. It will be ML2 per what? Per 2. This is for the work done. I hope you understand how we get this. So what follow? This is Q. This Q in physics is called electric charge. What do I call it? Electric charge. Electric what? Charge. Charge. And what is the formula? It is what? Current times time. Now current is what? Current, I told you the dimension for current is enclosed bracket capital A. Then we put enclosed bracket capital A here. What is time? The dimension for time is capital T. We have do that of electric what? Charge. All you need to do, wherever I'm saying Q, what will I be putting? Enclosed bracket capital A and this. It will now be enclosed bracket what? Capital A and what? And what? And T. Are we together? All we need to do now is that you try and what? You try and raise this up. You can leave your answer like this or raise it up anyhow you want. It will be M. What follows? L 2 per T is here. T is common here. Pick one. Minus 2 is the power here. Divide will change to what? Minus. What is the power here? 1. Put 1 here. Then what are we at? This when is coming up, it will also be, this power is 1. When it's coming up, it will follow through this channel. It will be minus 1. A now will be what? Minus 1. All we need to do now, we have it to be ML to ML square T per minus 2 minus 1. It is minus 3. Then we have A to be minus 1. This is the answer. But Jamb do some trick. You cannot have this, maybe you can't find this in your options. They can still put it like ML square T per 3. Based on the definition, A can still be the same thing as I. Can be the same thing as what? As I. Then they will put per 1. This is still the same thing as this. In case they didn't put A, they can put I. Then what will be the dimension unit? Kilogram, meter square, seconds per 3. What follows? This will be what? Ampere per ampere. This is the what? SI unit for that. Now, another question. Let's see. This is question number 1, viscosity. And this is 3. This is 4. This is a Jamb question. This is also a Jamb question. But let's quickly see something on this. Viscosity. What is the formula that should come to your mind? Don't forget to like, share, and also what? Subscribe to this channel if you are new, and for more update on our what? On our video clip. Drop your any observation on the comment section, and we are going to attend to that. Now V equals to force all upon what? All upon area times what? Velocity. This is the formula for calculating viscosity. Already we have known the formula for calculating force, which will be, let's firstly do the dimension for this, which will be what? ML, that is this, per what? Per T. This is for the force, isn't it? All upon, this is area. Area is what? I told you we have done that dimension. You don't need to still ask me that one. It is L square. Please don't note that. Then times what? What is velocity? Velocity is what? It is, I think, have you done that? Yeah, we have done that. Which is L per this. I hope how you get that. So this time, displacement over time. Then this displacement is L. Time, you raise it up. That's what we did here. Now what follows? You compute this together and you get your answer. It's very simple. V will now be, this is M. Firstly put M. We have L. We also have L here. You can match this. Let's quickly match that one together first to avoid what? Confusion. This and this, we have how many L? Pick one L. as law of indices. What is the power that this is raising to? 2. Times we change to what? Plus. What is this that this is raising to? It is 1. Are we together? Now what follows? We have t power 1. Are we together? This is the numerator, this is the denominator. Now what follows that we are having? The second thing to do now, is that match them together. V will now be m l t per 2. Are we together? Divide by, this is l, 2 plus 1 will give us 3. Are we? T per 1. Now try and still compose this together, compute them, which will be m. This now is l here, pick one l, that is law. This is 1, it's raising to 1, this is 3. 1, divide we change to minus in law of indices, this is 3. What follow? We have t, pick t here, pick 1, minus, is having minus 2. Divide we also change to minus. Then this power is minus, open a bracket for that to separate them, then put minus 1. All we need to get, V M L, hope you are getting it. 1 minus 3 will give us what? Minus 2. Are we together? Then t minus 1. Minus times minus in mathematics it is what? Plus 1. Minus times minus is plus. Plus times minus is what? Minus. Then what we need to do, V will now be what now? V will be what now? V will be ml per 2 t. Minus 2 plus 1 will give us what? Will give us what? Minus 1. This is the dimension for what? For viscosity. What do I call it? Viscosity. Viscosity. Now, what will be the dimension unit? Mass, it is what? In kilogram. This is in meter, but it's having per 2. We have t, which is in seconds, standard form. There is per 1. So this is the dimension what? Units of that. Are we together? Which of the following is a dimension of surface tension? That is a beautiful question. How your mind must ring on this surface tension. What is the formula? Just come straight. Leave the answer options and let's quickly see surface what? Tension. Surface tension is where we have force all upon distance. Force all upon what? Distance. This is the formula for calculating surface tension. Already you have known what a force is. You have done the dimension. What with that? Capital M. I think by now you have memorized this, right? Yeah, that is lovely. Now this will be what? ml per what? Per 2. This is what we are having. All upon, what is this? Distance is what? Distance is L. Are we together? Then this, match them together. Hence now will be what? M. This is 1. Minus the power. Are we together? Now L, pick one L. This is 1. Which is 1. 1 minus 1 because of this division sign. What are we? Then put T minus 2. There's not anything here, right? Hence will now be what now? M, L. 1 minus 1 will give us what? Will give us 0. This will be per 2, isn't it? Now S will now be what now? M. In law of indices, anything raised to power 0 is what? 1. Are we all together? 2 raised to power 0, 1. 100 raised to power 0, 1. It will now be M times 1 times T minus 2. Or will now be S equals to M per what? This. This is the correct answer. This is the dimension for what? Surface tension. What will be the dimensional unit? Which will be what? You know, we are under measuring and unit. It will be what? Kilogram per second square. Kilogram per second square. What will be our options? Correct one? Is it this one? No. Is it this one? Yeah. Let's match it. T per 2. You can see it. So for this Jamb question, the correct answer is what? B. Are we together? Please try and solve so many things regarding it. All you need to know is just the formula. Are we? Let's quickly attend to this question. Jamb 2019, question number 2. And it is also repeated in what? In Jamb 1987, question number 1. The dimension of impulse. The dimension of impulse is what in these options? The dimension of impulse is what? What in this option? You know, what we ring to your mind is what is even the formula for impulse. Know that the second law, which is second law of Newton, states that the rate of change in momentum is directly proportional to the what? to the what? To the come to your mind now is that impulse. What is even impulse? Impulse is from what? Impulse is now in these particular questions, first to come to your mind is what? Impulse. And know that when you are dealing with impulse, it has to be a relationship, a relative motion to what we know as Newton's law of motion. The second law of Newton's law of motion. What is that law? F equals to m in a bracket v minus what? U. Close the bracket all upon t. This is the second law of Newton. Newton's second law of motion. The rate of change in momentum is inversely proportional to the what? To the time, and directly proportional to the force. Now that's not what we are going. I want to use this to derive the formula for calculating impulse. All you need to do, put 1 here, then cross multiply. This is facing this one. It will be what? Ft equals to what? M in the bracket v minus u. Final velocity, initial, mass. So all this one now are momentum. What do I call it? Momentum. So they can ask you in another question which I'm not going to do, that find the dimension of momentum. Momentum is just mv. So you have to, dimension for mass is m. That of v is L per 1. So you match them together. That is just the dimension for momentum. So that's not where I'm going. Now this Ft, Ft in physics is what we call impulse. Ft, force times time. So if I ask you now to define impulse, it is the product of force and time and its time taking. The product of force and its time taking as a result of what? Newton's law of second motion is what we call what? What we call this. That means impulse now, which is I, is still the same thing as what? Change in what? It's still the same thing as momentum, which is this. Or change in momentum. Momentum. Are we together? We are not. I think I've tell you what a momentum is, and I've do the dimension of momentum. So impulse now, class, what will be the formula for impulse now? It is Ft, not full time. It is force and what? Hand time. Are we together? Now it's very simple now. Since we have known that our what? Our impulse that we are asked in this question is Ft. Whenever I'm seeing impulse, what will I be putting now? I'll be putting in what? F what? Ft. What would that be? I will be what? Ft. Force times time. Are we together? Now already we have known the dimension for force, which is capital M L per what? Per 2. I think we have done that in series of 9. This will be what will be the dimension of this capital what? Times what is joining them together is times what will be this capital what? Capital T. Let's match them together. Capital M L T. Pick 1, law of indices. What is this power raised to? Minus 1. Times we change to what? Plus. What of this is having invisible 1? 1, which will now be M L minus 1 plus 1 will give us what now? Minus 1. This is the formula for what? This is the dimension for what? Impulse. Then the SI unit is kilogram, meter, seconds, per seconds. What will be the correct options here? Let's see the correct options here. Is it this one? No. Is it this one? Yes. B is our correct option. This is ml per what? Per time. Are we together? That is that under that. If you find this video useful, helpful, don't forget to subscribe on this channel. Don't forget to like and also what? Share. My own work for you today is what will be the dimension for capacitance. You to go and try that. Find the formula. Find the formula and do that. Number 2, what will be the dimension for electric potential? You can drop your answer in the comment section and I will attend to the questions and we'll see if you are actually right. Then number 3, what of density? Is a Jamb question. Density, mass over volume, find the dimensions for that. Let's stop there. I still remain my humble self, Akorede Oluwayinka Hassan, a sub academic online class. Barakallahu fiik.